Let's begin with chapter 7, further trigonometry. And let's start with angles of elevation and depression. Now this video will only focus on angles of elevation. Angles of depression will be done in another video. Now hopefully at the end of the lesson, you'll be able to achieve the following objectives. Now, let me introduce you to the concept of angles of elevation and depression by using the following YouTube video. So please follow these instructions and watch the following video in YouTube. So please pause my video now. What did you learn from the video? The video tells you about angles of elevation and depression, and those two angles are what you experience in your daily life when you look up at an object or when you look down at an object. Those actions define the angles of elevation and depression. Alright, so when you look up at something, you are actually creating an angle of elevation. And how did the video teach you how to draw the angle of elevation? First, you draw a horizontal line, and then from your eyes to the object that you are looking at, you join them with a line of sight, and your angle of elevation is measured between these two lines. Similarly, when you look down, you are actually creating an angle of depression. And how do you draw it? Horizontal line, line of sight, and this is your angle of depression. Okay, let's explore further. This man is looking at his foot, which is on top of a cabinet. He's looking up, so obviously it's angle of elevation. So once again, how do you draw the angle of elevation? You draw the horizontal line, you draw the line of sight, and this is your angle. Now, normally how will you be asked regarding angle of elevation? You will be asked to find angle of elevation of the fries from the Incredible Man. Now, take note of the following. Angle of elevation of something. That something will be the object that is being looked at. Okay, in this case is the fries. Okay, from something, the object that comes after the word from, that is the object which is looking. In this case is you. Now, why am I emphasizing this? Is simply because I don't want you to misinterpret the question in the future. Learn to identify which is which so that you draw properly. Okay, let's proceed. This dude is looking down at his foot. Okay, looking down means angle of depression. And once again, you draw a horizontal line. And where is your line of sight? Here. And therefore, your angle of depression will be where? Here. Okay, and normally how will you be asked? You will be asked to find the angle of depression of something from something. Once again, angle of depression of something, that something is the object being looked at. Angle of depression from something, that something is the object that is looking. Alright, and from the previous slide and this slide, you can see that we always draw the horizontal line at which object? We draw the horizontal line on the object which is looking. Alright, let's proceed. What are the important points you learned till now? When you want to draw angle of elevation of or depression of one object from another, there are three things you need to do. First, you need to identify which object is which. Object A will be the object being looked at. Object B will be the object which is looking. Once you know which is which, you draw your horizontal line at the object which is looking. After that, you draw the line of sight by joining these two objects. So 3 things here: identify, horizontal line, line of sight. Okay, let's proceed with example 1. Now please pause the video and read the example carefully. You are shown here a building and you are the black circle down there. Okay, you are given the angle of elevation is 60 degrees, but it's not drawn for you. So before you can do anything or calculate anything, logically you need to draw the angle of elevation. And recall, to draw, you need to do 3 things. First, identify which is which. Yes, the top of the building is the object being looked at, and you are the object which is looking. Okay, next, what do you do? Okay, before that, where is the top of the building? Yup, it's there. Okay, so next you draw a horizontal line at where? At the object which is looking. In this case, is you. Fortunately, it has already been drawn for you. Now, you draw the line of sight. And then, where is the 60 degrees? It's over there. Okay, so far so good? Alright, now, what do you see here? What figure do you see here? You should see a right angle triangle. Now, why should we rejoice when we see a right angle triangle? Because right angle triangles are the simplest triangles, are the simplest figures to deal with. There are 2 things you can apply on a right angle triangle. What are they? Pythagoras theorem and Tuakaso. In this case, we use Tuakaso. Okay, we cannot use Pythagoras theorem because Pythagoras theorem requires 2 sides. And you don't have 2 sides here. You only have 1 side, which is the 50 meters. So let's apply Tuakaso. What is Tuakaso, everyone? Sine, cosine, tangent. And sine, cosine, tangent is always attached to an angle. Look at your right angle triangle. What is the angle inside the right angle triangle? Okay, besides the 90, we don't use 90 degrees inside sine, cosine, or tangent. It's the 60 degrees. So look at the 60 degrees and identify which side is the opposite side to 60 degrees, which side is the adjacent side to 60 degrees, and which side is a hypotenuse to the 60 degrees. The 50, what is it? Adjacent. Okay, and this question asks us to find the height, so the height will be here. I label it capital H. And what is this height to the 60 degrees? Opposite or hypo? Opposite. And my hypo is the line of sight. Okay, now when you use Tuakaso, okay, you only need to use 2 sides, 2 important sides. In this case, I want to use H and 50. Okay, the question is not interested in finding the line of sight. So we use the H and the 50 meters. So which trigo function uses opposite and adjacent? TOA, tangent. Now sine, cosine, tangent, they are always attached to an angle. And what angle do we focus on here? 60 degrees. So tangent 60 degrees. And we know it's opposite over adjacent. What is the opposite? H. What is the adjacent? 50. So we write it down. And from here, it's straightforward to solve it. Okay, just put tangent 60 over 1 and then you cross multiply. Now, why do we cross multiply? Because we don't like to deal with fractions. We cross multiply so that we do not get any more fractions. So after you cross multiply, the 50 will go to tangent 60 degrees and the 1 will go to H. So 1 times H is simply H. press this in your calculator. If your answer is not exact, round off to 3 sig fig. Okay, so pause this video, read through the steps again. Any question, please discuss with your partners first. So what did we learn from example 1? Okay, before we even did example 1, what did we do? We learned how to draw angle of elevation and depression. And then we applied that in example 1. And what did we discover? We discovered that we can draw right angle triangles using angle of elevation. And after we draw the right angle triangle using the angle of elevation, we can simply use tuakaso to find the unknown angle or unknown side. So this is what we did. Okay, we draw the angle of elevation, and then we realized that we can construct a right angle triangle, and then we apply tuakaso, we use tangent, and from this trigo function we are able to find our unknown, which is the height of the building. So how did we proceed? We started from drawing angle of elevation to constructing a right angle triangle using the angle of elevation. So what is the moral of the story? What is the important thing here? Always construct a right angle triangle using angle of elevation. Why? Because right angle triangles are easy to use. How? Tuakaso. Okay? So whenever there are questions involving angle of elevation or depression, always construct a right angle triangle using that angle, and then solve whatever it is using tuakaso. So far so good. Now let's proceed to another example. In this case, a cockroach is looking up at the man's songkok. You are given the man's height, how far the cockroach is away from the man, but you are not, the picture does not indicate the angle of elevation. So you need to draw it. So once again, when you draw angles of elevation or angles of depression, you need to do 3 things. First, identify which is the object that is looking and which is the object that's being looked at. Next, you draw the horizontal line. Where? At the object which is looking. Who? In this case is the cockroach. Okay? Fortunately, the horizontal line has already been drawn. Next, line of sight from the cockroach to the top of the man's songkok, and then indicate the angle of elevation. Okay, since this question asks you to find the angle of elevation, or since in this example the angle of elevation is unknown, we label it as X. Okay, now what? What did we learn from the previous example? With the angle of elevation, you can construct a right angle triangle. Do you see a right angle triangle here? Yes. Okay, I simplified it with this diagram. Okay, now in example 1, the unknown was height. In this example, the unknown is the angle. So focus on the angle and tell me which side is opposite to angle X, which side is adjacent to angle X, which side is hypotenuse to angle X. Okay, 1.73 is opposite and 0.45 is adjacent. Okay, we don't need to use the hypotenuse because we don't want to find it. So what function uses opposite and adjacent? Towa, tangent. And what do we put inside tangent? The angle. In this case, our angle is X, equals to opposite over adjacent, simply 1.73 over 0.45. Okay, now How do we remove the tangent from the x? We use tangent inverse, or like what some of you name it, tangent power minus 1. Once again, what is x? X is the angle. If the value of the angle is not exact, do you run off to 3 sig feet? No. All angles in degrees must be in 1 decimal place. So far so good. Pause this video if you are still unsure. Discuss with your partners, alright? Okay, let us go through example 3, which is slightly harder. Read the question, please. Pause the video. Alright, what do you see here? There are now 2 cockroaches looking up at the man's songkok, and you are given 2 angles of elevation. In example 1 and 2, you only have 1 angle of elevation. And what did you do with the angle of elevation? You draw a right angle triangle. So logically, if you have 2 angles of elevation, you need to draw 2 right angle triangles. Do you see the logic? Okay, let me show you. First, let me draw the angles of elevation first. Okay, as always, identify which is which. Okay, and since we want to find the distance between the cockroaches, let's use algebra and let this distance be x. So, angle of elevation of the top of the man's songkok from A. The horizontal line is already given, line of sight, and my angle of elevation is here. Now, focus on cockroach B, line of sight, and angle of elevation is 40 degrees. And like I described just now, 1 angle of elevation, you draw 1 right angle triangle. So 2 angles of elevation, you draw 2 right angle triangles. Okay, there are actually 2 right angle triangles here. Now let's focus on this diagram. This diagram can be split into 2 right angle triangles, the big one and the small one. Okay, pause this video if you cannot see properly. Okay, then how do I calculate x? Okay, use your powers of observation and see that x is simply this length minus this length. Pause the video if you cannot see. Alright, so how do we find this length? Okay, right angle triangle, what do you use again? Tuakaso. You should get the following. Now, if you don't understand how I obtain these values, please pause the video and ask your friends. Okay, like I said, it's just Tuakaso. Press this in your calculator and you get the following. If your answer is not exact, you run off to 3 sig feet. Okay. If it was angles, you run off to 1 decimal place. Okay, now pause this video and read through the steps again. Compare what is the difference between example 1, example 2 and this example. Example 1 asks you to find height. Example 2 asks you to find angle. Example 3 asks you to find separation between 2 objects which are looking at something. But the steps did not change. What were the steps again? Always draw a right angle triangle using the angle of elevation, and then apply Tuakaso. Alright, if there's no problem, let me finish this with something for you to think about. Okay, like I said, we can use angle of elevation to find the height of something. Now, this man is looking at the top of this tall structure. So, obviously, there's angle of elevation here. So you draw the horizontal line, you draw the line of sight, and then you label your angle, you form your right angle triangle. And notice, is he able to find the height of this tall structure from this right angle triangle? No, because he will only be able to find the height of this thing. How then is he going to find the height of the structure? If you look carefully, it's simply this height plus the height of the man. Okay, try to relate this when you observe the top part of a building or any tall structure. Next, something to relate to. There are three friends here. Both are looking up at a tall structure. Can you tell me which of them has the largest angle of elevation? Which of them is looking with the greatest angle of elevation? Try to relate this to your daily life. When you're looking up at a tall building, do you look up with a greater angle of elevation when you are closer to that building or when you are far away from the building? Try to relate. Next, there are two people here. One is taller than the other and both are looking at the flying object. Can you tell me whether is the taller person or the shorter person who will look with a greater angle of elevation? And lastly, this is me standing in front of you. Now, which of you will be looking at my songkok with an angle of elevation? Okay, I will end my video here. Please follow the next set of instructions from the teacher.